everyone, and welcome to Untamed Unfiltered. I'm Amanda Nicholson.
I am Aaron Provencio, and today we have two very special guests, Dr. Justin Brown and Dr. Mark Reuter. How's it going today?
Great. How are you guys?
Doing great.
Good.
Awesome. Well, thank you guys so much for joining us today. I am so excited to see you both. And this Untamed Unfiltered is just a chance for us to take a deeper dive into each of our Untamed episodes. So when we were planning this episode to talk more about our wildlife research episode, I instantly thought of the two of you. I definitely firstly thought of Mark because he was supposed to be in this episode, but sadly he was cut for time. So I feel badly that we had a whole interview with him and everything, and it didn't make it in. But here's his chance to share some information with the world. And of course, Justin, we've known for a long time as well, and lots of good stuff in the wildlife research field. So I felt like you guys were great. You would be great to talk to for this, and just talk about wildlife research, some projects you've worked on over the years, just kind of whatever is new and exciting in the field. So I guess before we get into that, why don't you give us just a rundown, both of you give us a rundown of your career path and what you're doing today.
Okay. I'll go first, Justin. So I'm a Kansan, a proud native Kansan. So I went to veterinary school and undergrad in Kansas. And after vet school, I was fortunate enough to get the veterinary internship at the Wildlife Center of Virginia. So I was the intern at the Wildlife Center from 2007, 2008. And then after that year, I came down to Georgia to do a PhD, where I first stumbled into Justin, and was here for several years and finished my degree. Worked for the U.S. Department of Agriculture for a few years before returning to Georgia and SCWDS at the Southeastern Cooperative Wildlife Disease Study, which is now where I am. And yeah, we're a cooperative regional wildlife research, diagnostic, and service unit. So we're pretty enveloped in the wildlife research arena.
All right. Well, I'm not sure Kansan is a real word, but we'll let him.
Sure it is.
As opposed to that, I'm a Virginian. So I'm from Northern Virginia. I went to vet school at Virginia Maryland Regional College of Vet Meds, Virginia Tech. And I actually, during my summers, after my first year through when I graduated vet school, I worked at the Wildlife Center of Virginia on research projects. I spent most of the summers and breaks there working in the hospital, and you all did a great job of teaching me everything I didn't know about wildlife health and taking care of a young vet student. So I always had a good relationship with you all and have sort of cherished my time there. After vet school, I went down to SCWDS and University of Georgia, where Mark is now. Did a PhD down there working mainly with flu in wild birds, and then stayed on as a postdoc and a research scientist. So in total, I was down in Athens, down at University of Georgia for about 10 years. And then I came up and was the state wildlife veterinarian for Pennsylvania for 5 years, and just recently moved to Penn State University, where I'm teaching in the Department of Vet Biomedical Sciences there. So
Very cool. And so this episode is all about research, obviously. And so I'm wondering if the two of you could kind of go through what research means to you, and then especially why research is so important in this field of wildlife science.
Okay. Yeah, research, it's funny, the Wildlife Center, my time at the Wildlife Center was one of my favorite times. It was really like a year of living a childhood dream. If you would have told me when I was, 10 or 12 years old, looking at animal bones in my grandma's pasture, that I would have done that for a year, it would have been I would have said no way, and so it was a really fun time. And one of the things that I realized during my time there, primarily in a clinical role, so receiving patients, treating patients, working with individual animals to get them out the door. One of the things that really I learned about myself there was that it was a lot of the things that really excited me about wildlife health were broader questions, and really at the population level. It was things getting away from individual animal care and really pointing me towards, how often does this happen? Why does this happen? Who else does this happen to? What's the impact? These kinds of questions. And so it really confirmed with me that I did need to go on and do a PhD so I could kind of take that next step into a more primary research role. But with that said, what I learned at the Wildlife Center in my time there was fabulous. And research in I don't think it's specific to the wildlife field, but really any field. Research really kind of drives everything in many ways. I mean, we know so much about the world because of research, regardless of discipline. And so, having that sort of, curiosity, the ability to kind of ask the right questions and frame it, in a way that you could design a study and answer a question and sort of, take a little step forward in the collective knowledge, of wildlife health and wildlife science. That's kind of the what I enjoy about it. And I do it's easy to get kind of lost in how large it is and the scale. And so I've really kind of had to retrain my way of thinking of like, I'm just going to learn this much, right? And probably when we learn this much, we're going to ask 10 more questions and find 10 more paths to walk down. So it's just really like a little bit at a time that you, in an individual's career, like you typically could progress something, but it's definitely fun. And you get to meet a lot of enthusiastic and smart people, way smarter than than you, so, but I'll kick it to you, Brown.
Yeah, I think Reuter and I are pretty similar. When you think of veterinarians in general, and specifically wildlife veterinarians, you have to wear a lot of hats, right? You have to be a clinician at some times, a diagnostician or a research scientist. And I think Reuter and I are both probably hot-wired to be more scientist-oriented. In many ways, I think we're probably wildlife biologists that went to vet school. And I think we both really enjoy it. I think and I know that I can speak in some respects to him as well, because we shared a cubicle for so many years, and I think we think similarly. But I think what I enjoy most about it is we both really like applied research. So not theoretical things, more research that solves a specific problem. And what I like about that is that you can always look to do things better, right? And research can be all sorts of things. It can be clinical problems of how do we treat this animal better? How do we, anesthetize it better? How do we collect samples better, test for this disease better? It's just sort of putting a question to a lot of the things that we're already doing. And I think what I like about it is that we continue to advance the field, so that hopefully a lot of the things that we're struggling with now and stumbling our way through, that in a few years from our research, they'll be doing it better. And so sort of gets to bigger questions, and that's sort of, I think, what I like best about it.
That's awesome. And that's a really interesting way of putting it as wildlife biologists who went to vet school. But you're right. I feel like over the years at the center, I've gotten to meet and work with a lot of interns and veterinarians, and everyone kind of has their, they're all veterinarians, but everybody has like a specialty or angle or like little niche in this field. So
yeah, when I met my wife and we were getting married, my mom was really excited because she said that it would be great to have a vet in the family. And so after that sort of insult washed away, she was probably pretty correct.
Yeah, Brown doesn't count as a real veterinarian. Neither do I. Yeah.
I also have to share with our viewers that Mark was talking about when he was at the Wildlife Center as an intern. So Mark was there when little baby Buddy came in as a little tiny nestling with his giant pox lesion. So I know that is, that was like a pinnacle moment for many of our supporters out there. And I can picture like this image of Mark with holding little baby Buddy as he was like going to get an MRI or something.
Yeah, and it's funny the connection to Squidus with that case too, because the original, so when the NESCAM originally or early on, VDGIF ascended, they pulled him down, they did a little biopsy of the lesion growing from the beak, and that biopsy was actually sent here to Squidus for confirmation that it was actually avian pox. And so it was a funny little connection, just that one bird connecting a couple of places. So I followed the biopsy here. So.
I feel like that's probably true. We probably send a lot of stuff to Squidus, but it's always like weird, like animal parts or things that came out of animals or something. I think about that sometimes, like, oh, going off to see Mark.
Right.
Well, can you guys share with us, I know you've done a lot in your careers thus far, but maybe share with us one or two of your most favorite, most interesting research projects that you've been a part of?
What, I guess one of mine would be something that kind of took me outside of veterinary medicine a little bit, and that was and we're starting up some of this work here now in Georgia, but one of the diseases that I study primarily is known as hemorrhagic disease. So it's a virus transmitted by small biting insects called culicoides to white-tailed deer, among some other ruminants. It's caused by a couple of viruses, but it can be a pretty devastating disease for white-tailed deer. They're quite susceptible, and it can lead to really high mortality during an individual outbreak in deer populations in some parts of the country. But one thing I've always been very interested in is the insect side of it. And a lot of diseases that are pathogens that are transmitted by vectors, as we call them, insects, they're a little bit more complicated and interesting to study because there's such a connection to the environment. Weather variables, long-term climate trends, soil chemistry, land use and animal use patterns on the landscape, and all kinds of factors. And so in that disease system, we don't know a whole lot about some of these culicoides populations, and there's probably about 150 different species in the United States, but only probably a handful are responsible for actually transmitting this virus to deer. And so trying to understand where did some of these different culicoides breed? So these are insects, mosquitoes, you might, if you set a cup of water on your back porch for a few days, it's going to end up with a bunch of mosquito larvae in it. You see them swimming around in there. Culicoides are a little bit different. They like some muck in there. So they'll breed in like mud, like really moist saturated mud, or maybe tree cavity litter or other things like that. So they need that sort of semi-aquatic environment. But I've spent a lot of time with entomologists in the field really trying to understand and investigate where different culicoides species are actually breeding in the environment. And so those projects are just really interesting because you look at the world very differently. If you're walking into it just looking for deer, into a landscape, you look at one layer. If you're going there trying to think like, oh, if I was a culicoides and I needed to lay some eggs, where would I do it? You just look at the forest or the prairie or wherever you are in a completely different way. And it's actually pretty exciting to start to discover this whole like layer of complex ecosystem and habitat that you kind of just walked over and passed every other time you went through the forest. And so that's been a pretty a pretty cool and exciting, research area for me, because it's so different, and then it kind of connects you to the habitat and to the ecosystem in a little bit differently, and it makes you think of like that insect interaction on in the greater disease system a lot more. So that's been some of my cool stuff, because it goes back to my curiosities. It's why I do what I do. I'm interested in almost anything nature wise. So it allows me to sort of, get down and look in the mud and understand the mud and what's in the mud and how does it connect to other things. And so it just feeds that like little curiosity that kind of sparked why I wanted to do everything I do anyways. You go, Brown.
All right. Well, I think probably one of my more, the one that I think of that was probably one of the most fulfilling was some of the recent work we've done with West Nile and grouse. Grouse, rough grouse, one of the coolest birds ever. It's got all these cool adaptations to live in the forest. It's the state bird of Pennsylvania. It's got a passionate group of people, sportsmen that hunt it. It's just an awesome bird. And when I took the job at Pennsylvania, the grouse numbers were not doing well, as they haven't been for much of the Pennsylvania and South in that part of the country. And a lot of it is presumably and likely driven by just a lack of habitat, so young forest habitat that they need. But what we started to see when we looked at the data a little bit closer was that when we looked at our sort of counts for rough grouse each year, they would be low when it was a bad West Nile year. And it was a pretty nice trend, but again, as scientists, you sort of have to, there's a lot of things that could confound that or be biases or something like that. So we started to research it a little bit more. And I think what I liked about it was just how collaborative it was with different groups of people. So field biologists, hunters, Department of Health, all sorts of people that contributed to it. And that's sort of what I like, is sort of the multidisciplinary part. But what we found is, as you think it would be an easy thing to figure out, West Nile is one of the most studied pathogens that we've had in the last decade. Rough grouse is one of the most popular species in the East as far as an upland game bird, but we didn't have almost any information. All our West Nile data was from the suburbs and urban areas, which is like the opposite of where rough grouse are. And rough grouse, if they die in the woods, the chances of us actually getting that to a diagnostic lab to get diagnostic data is like impossible, right? So we actually had to do all sorts of things, looking at hunter surveys, doing challenge studies, and we pieced together sort of a really cool story and defined the problem. And if it stopped there, I think it would be neat and it would be fun, and I'd like the science. But what I liked about it is that we could then take that data and make it turn into differences or changes in how we manage it, right? So now in Pennsylvania, we have an adaptive system where we can change the hunting season or modify it based on how bad the West Nile year is, based on how bad grouse populations are. And so we can have sort of an adaptive management system that we've changed it to. We're looking at areas where we can make habitat for grouse in areas that are not good for mosquitoes in West Nile. And so it's sort of gone from this theory that West Nile is killing grouse to using the science and defining the problem, improving it, and then implementing management to sort of hopefully improve or fix the problem moving forward, or at least make it not as significantly bad. That was something, just to see something, your research go through to actually a management action is sort of what I like best about that.
And the two of you continue to bring up this word curiosity, these questions, right? That so much of the scientific process is driven by questions. You see a correlation in the data, you see something you hadn't seen before. The what's, the whys, the hows are kind of what begins this series of inquiry that eventually, like you were saying, Justin, ends up with real application in the field. And I'm wondering, for the viewers out there who might not necessarily know kind of how this process begins, how do you go from a question and work it all the way through to a research project? And then additionally, how do you decide which question to follow through with?
That's a really, really good question. It's probably part of the reason I had to move away from Rooter, because when we were together, we would come up with way too many ideas. Neither of us were really sleeping. So, sometimes you have to pick and choose what idea you go for. But I think, the first thing you do is look at the literature, see what's out there, see what has been done, and see if additional research is even needed. See if the data exists, or do you actually have to go get it? Because a lot of times, if you look at SCOTUS down there, I mean, they have some of the best diagnostic data that is, decades long. But they may not have the data you need to answer that question. And so in that case, if they don't, then you have to go out and get the data, get the samples, and generate that. So I think it's not as easy as just saying this would be a good research question. I mean, I think there's so many of those out there, but you have to pick and choose ones that, is there an actual problem, or is there a question that's legitimate? And what's the likelihood of you actually getting the data that you need to address that? I mean, there's tons of questions out there that probably we would love to investigate, but we can't get samples. We can't, we don't have the diagnostic tests. We don't have money. And so a lot of that drives, unfortunately, what questions and research you actually can pursue.
Yeah. And it's just it's just the reality of wildlife health research is, Justin mentioned it, is funding. There's a ton of excellent questions to ask or research studies to design, but if it can't be justified in a manner to a funding body who will say, oh yeah, we'll give you 100,000 or 500,000 or $1 million, whatever it is, because a lot of these studies are pretty costly. It can be a challenge, and so it's just the world we live in of trying to justify, the reason for the research study, and what it might, what's the impact of it, what's the benefit of it, can it make a difference, is it really important, who does it impact? So that gets a little bit complicated sometimes, and but yeah, that's where it sort of takes some creativity, I think, within the wildlife research arena to try to secure some research dollars to answer some of those questions in groups where, say if it's a problem that directly impacts, say, public health or cattle health or domestic animal health, like those are a little bit easier to sort of justify, and you have more doors open in terms of funding opportunities. But if it is a strict wildlife problem, your world just narrows a little bit in terms of where you're able to seek funding, especially when it's sort of like just a basic question or an initial step towards something that might become bigger. So that's a constant challenge for wildlife researchers.
And one of the things that we often, it's often not one big project. So sometimes for many problems, you take a stepwise approach. And that's one of the beauties, I think, of Wildlife Center Virginia. And one of the things they've been amazing at over the years is using the data that they have to generate sort of what might be a preliminary study that's good by itself and provides useful information by itself, but maybe a stepping stone to that big grant that may answer a broader question, right? So if you do all those retrospective studies that have been done there, all the studies that have been done there to use the data that they already have, that they get just in the cases that they do, that can oftentimes be sort of that first step to getting those larger grants that you can go after.
Yeah.
That's where the longevity of the Wildlife Center really helps too, because you're not talking about a year of information, you're talking about decades of information. Right. And that's really powerful when you can have that sort of staying power and that long-term information. You can start to see trends over time and a lot of really good sort of detail in a system that you just can't capture, in a snapshot.
Yeah, that's something that Ernesto, our current vet director, said in the episode too, something to the effect of every piece of data is important or can be important. And I know that we certainly try and collect as much as we can in terms of information and recording all that so that we have it at some point. If someone wants to come in a couple years and do a retrospective study on something that's already happened, hopefully they have a huge source of data to jump into. But But yeah, kind of definitely, I know they have to prioritize what projects they want to get into, what sort of, how expensive is it to send off a bunch of samples and this and that and all that. But I know one project that it's a little bit older, because it happened like 19 years ago when Justin was there, was the project on box turtle aural abscesses, which I always have thought that has been really interesting. It also, I also think it's interesting just because I remember that happening, and Justin was there as a student the summer that I started working at the Wildlife Center. So I feel like, Justin, you were like maybe one of the first people that I met there that summer. I do have like this recollection of you and me trying to like figure out who everyone was and what's happening. And
I can't remember, Amanda. Did he look like this at that time, or did he look a little different?
I mean,
not dissimilar. It changed a lot. It changed a lot. I feel like every time I came back to the center, they were like, "What? Yeah, like what?
Who is this guy?"
Yeah.
Yeah, I think not dissimilar. But I mean, yeah, Justin's a man of many, many looks over the years. So that's
Oh my gosh, yeah.
But you were there as a student, and I was there as a new employee trying to figure out what was happening. And you guys were working on this cool project of taking all these samples and looking at all this information about box turtles and trying to figure out why box turtles were coming in with these giant aural abscesses. And I don't know, I'm wondering, like, as a younger student at the time, were you I guess, like, were you aware of how cool that was, or how cool it was going to be? Because I feel like that's something that we still talk about all the time, of like, we know this because, and we share this information.
Yeah, no, I was, all four years that I was at, or I guess it was 3 because it was after my first year, all 3 years that I was at Wildlife Center, I was completely stoked. I mean, it was just to see that many animal species come through. You know, Jonathan Sleeman was there, Tara was there, everyone I met was just, my eyes were dilated. It was awesome. And to even have your own project on top of that, if you just let me hang out in the clinic, I would have been excited. But to have sort of my own little project, I mean, it was awesome. I think it's one of those projects where, being down at Squidus, in a diagnostic setting, you see a certain type of animals come through, but there are a lot of things that fall through the cracks of those kind of diagnostic data, right? So like things that maybe cause mild disease, things that may not kill the animal, things that are in a species that you can't get your hands on, again, like a grouse. Like those kind of things oftentimes fall through the cracks of a lot of our historic wildlife disease surveillance programs, right? And so I think one of the things that was really cool about that was to study aural abscesses in the setting where we see those, which are our rehab centers, wildlife hospitals, and to tie it back to sort of a disease that we were seeing in animals and how that may relate to ecosystem health. That was sort of my first step into the fact that wildlife could be sentinels for something. And so I think it really changed the way I looked at wildlife health, just that project being not just a disease of individual animals, but one of populations, and one that could involve a bunch of factors in the environment to result in disease in an animal. So yeah, I mean, it was amazing. Yeah. And to work with box turtles, I mean, that's like the coolest species around.
Real quick, Justin, I want to go back to something that you just mentioned. Could you explain this term that you used of sentinels?
Yeah, and so it's sort of like the classic canary in a coal mine, right? Where, domestic animals have varying levels of dependence on the environment and exposure to the environment. We bring them in at night into barns. We feed them complete and appropriate feed for them. They're drinking water that may be treated. Humans are even worse, right? We're drinking bottled distilled water and going out in the environment for like an hour a day, right? And so when you look at wildlife, they're immersed in it. They eat, they sleep, they drink, everything in the environment. And so a lot of times, if there is an unhealthy ecosystem, whether that's contaminants, whether for whatever reason the ecosystem is out of whack, then you may see that manifested in wildlife before humans and domestic animals. And so in this case, we were looking at the disease of where you get these sort of abscesses in the inner ear of box turtles. And it's a disease we see really commonly in the pet trade because of unclean environment when you have aquatic pet turtles, because of miscalculated or misformulated diets. But it wouldn't make sense that you'd be seeing that in a wild situation, at least on the level that we were. So we were trying to look at what factors could be contributing to that.
Mark, it's now your turn, because as Amanda mentioned earlier, for whatever reason, you were cut from this episode of Untamed, which is why we brought you in for Untamed Unfiltered. So you have been working on a study with tick surveillance. Is that right? Could you talk us through that a little bit?
Yeah, that's been another fun project I was going to mention. So and it's one of those very collaborative, multiple different layers of agencies and nonprofits and others that are involved in it. But in New Jersey in 2017, there was an exotic tick species found. It was on a backyard sheep. So it's called the Asian longhorn tick, and its native range is Eastern Asia, Southeast Asia, and it has invaded multiple countries in that region. It's a bit of a tricky one because it's got a unique reproductive approach that creates a situation where it can be extremely invasive and in very high numbers, and that is they don't really need males. So the female ticks can just start laying eggs. They don't need a male counterpart. And so in that scenario, you can see how quickly a population might be able to just explode because they're just laying eggs and hatching larvae, and then they're taking off. So the immediate question, it's found on a domestic species in somebody's backyard in suburban, semi-rural, semi-suburban New Jersey. And so, there's immediate questions that pop up, right? Is it established in that area? Are wildlife potentially hosts for this tick? Many tick species are capable of utilizing a variety of different animal species, including humans. And so there's a variety of questions that immediately emerge when you find a new tick species. And so agricultural agencies were certainly very interested and involved, state and as well as the U.S. Department of Agriculture, and then as well as wildlife agencies to try to understand the role and then potentially the impact on wildlife. And so Squidus, initially did some surveys of small and medium-sized mammals right around that area, and we begin to find it on raccoons and possums, and so okay, that the cat's out of the bag here, right? So with many problems, disease problems in America and in anywhere in the world, whether it's a tick or a pathogen, a lot of times it's not a strict one animal or one host issue. So they might affect domestics as well as wildlife. And so when you have those scenarios, you have possibility of big problems because, as Justin said, we have a lot of control over domestic animals. We can bring them into the barns. We can access all of them. We can treat all of them. But we can't do that with wildlife. They're free living. They don't understand borders. They don't respect borders. They have no reason to. So they freely move in and out of this pasture and that pasture in this backyard, or this flyway and that flyway. The scale is highly variable, but what happens is once a disease problem or a vector could get into a wildlife reservoir, as we might say, it's very difficult to control. Almost impossible in many situations, just because of some of those issues we mentioned. So we began to quickly realize it's not just affecting this sheep in the backyard. We didn't just find the first tick of this species in the United States. And so once we kind of established that it was there, we began to broaden, concentric circles, kind of get out from that area, say, well, is it outside of New Jersey? How about Maryland, Virginia, West Virginia? So there's this need to sort of ask a regional question. Well, where is this tick and who is this tick utilizing? And so we were certainly focused on the wildlife aspect of this, whereas agricultural agencies were asking domestic animal questions. But so we kind of, we reached out to all of the state wildlife agencies that are member cooperating agencies of SCWDS to start to do some surveillance of wildlife. We tried to focus on deer initially because we, through some local efforts there, realized they were a pretty good host. So deer and bear as well is what we kind of focused on initially on the state wildlife agency side. So we asked state wildlife agencies to, anytime you have your hands on an animal for a research project, or you find a dead animal, you're doing a mortality investigation, collect those ticks, send them to us, and we'll do identifications. So that was one method. But if you think of the species that a lot of state agency personnel routinely handle, it might be some of that, the deer and the bear and the elk and some of the larger species. But the tremendous diversity of animals that you see through, say, the Wildlife Center and other wildlife rehabilitation centers, you kind of can tap into a whole other suite of species. And so we quickly reached out to the Wildlife Center and a couple of other wildlife rehabilitation centers to say, okay, when you guys are receiving patients, we sent tick collection vials, protocol, little forceps, and you guys began collecting ticks from lots of species and hosts and coming through the center. And through that effort, we have confirmed this Asian longhorn tick on a variety of species just through the Wildlife Center alone, yielded a tremendous amount of information. And when we put all of that surveillance together, the state wildlife agencies, the Wildlife Center of Virginia, and a handful of other rehabilitation facilities, we were able to document Haemaphysalis, the Asian longhorn tick, on multiple avian and mammalian host species in multiple states. And so, that surveillance effort really, when you look at the distribution of the known distribution of Asian longhorn tick in the United States, without that effort, we wouldn't, there'd be a lot of holes in our understanding. And so that's been a project, a very collaborative project spanning many states and many people that has collectively yielded a ton of information in a very short amount of time about the distribution of this tick. And it's a tick now that many public health agencies are highly engaged in, as well as agricultural and wildlife agencies. So it's one of those ticks that that's gotten the attention of a lot of people for sure. So yeah, we'll have to do a little addendum there for that.
Do you close your eyes and see ticks? That's a lot.
I'm pretty numb to ticks these days. But yeah, it's a lot. It's a lot.
Well, I think before we let you go, I think we're dying to know, and I'm sure the viewers are too, what comes next for the two of you? Are there any exciting new questions that you're chasing after right now, or is it sort of the same things that you've been doing? What's next on the docket?
Good question.
You want to go first?
Yeah, I can. One thing that hopefully the viewers of this show are aware of, but it's one that we're acutely aware of, is a new pathogen on the landscape, at least in the United States, and that's rabbit hemorrhagic disease virus. So this is a virus. Again, there's this theme of in the disease world of things coming from other places and entering a new population and having significant effects, and that's this story. So rabbit hemorrhagic disease virus is it's been known to occur in Europe and in many parts of the world since about 2010. 2000 is when it emerged about, and then 2010 it really kind of popped in Europe. It's pretty devastating viral infection in many species of rabbits, some domestic and some wild, but it can lead, kind of like hemorrhagic disease of deer, it can lead to very explosive outbreaks and a high mortality rate. And so unfortunately, this virus, both domestic rabbits as well as many wild rabbit and hare are susceptible to it in the United States. And in March, it really kind of picked up in the southwestern United States and northern Mexico this winter and spring. And it's now as far east as sort of central and east Texas. And this is a virus that can move through movement of animals, whether they're domestic or wild, dead or alive, or through bedding, feed, equipment. It's a pretty infectious and hardy virus. And so it is definitely a threat to many North American species of rabbit and hare. And when you have if you have a devastating impact on a population of animals that's such a significant prey base, you can have cascades of effects, up to sort of scavengers and predators even. And so, and that's been shown in other parts of the world, and it's definitely not something that we want to have happen in the United States. And so we're kind of gearing up with diagnostics and outreach materials and sort of some research questions to try to hopefully get ahead of things on the prevention side of things, because we might not be able to ultimately slow the sort of expansion of distribution of rabbit hemorrhagic disease virus in the United States, but we should do our best to try. And the only way that's going to happen is if all different groups are bought into the situation and sacrifice a little bit and embrace sort of preventive measures that might help keep that virus contained where it is and not spreading into other, more other populations, some of which are vulnerable. There's plenty of vulnerable rabbit and hare populations in North America that we want to keep this out of. So that's one that hopefully everybody can be tuned into.
Yeah, I mean, I think primarily I'm looking at ways to get Reuter to collaborate with me, but I really can't get him to return my calls until I get on a show like this.
This helped a lot. Yeah.
He can't get away when I'm on this, but
That's what we're here for.
Thank you. It's been months. But honestly, we have a lot of projects going on, looking at mange in bears. We have some survival studies where we actually track how does sarcoptic mange, which is increasing. Obviously, you all are well aware of that problem in Virginia, but it sort of emerged, or at least was first detected in Pennsylvania and radiated outward. And so we're looking at the depth of that problem, sort of characterizing the mite, looking at the impacts on bears with survival, recovery, both with and without treatment. So we're doing some work with mange that we have ongoing, some work with muskrats. We've seen declines in muskrats over the last few years. So we're doing some basic information on survival and what are the causes of mortality in muskrats and what are some diseases that we see in them. But one of the things I think that I've just really gotten more and more excited about is just sort of defining what's out there. I mean, I think there's that classic saying that you have to define what normal is before you recognize and respond to abnormal. And it always seems like we are behind the 8 ball all the times with wildlife health. Like we ignore something until we find the Asian longhorn tick, and then we're like, okay, now we really have to figure out what's out there. Or we don't do any flu surveillance until H5N1 comes through, and then we're like, okay, let's figure out what's going on here. And so, more and more you see that really the best time to get a jump on some of these diseases is when you don't have it. So if everyone's looking for COVID right now in bats, that was something we probably needed a year ago, right? And so I think a lot of the projects I'm looking at now is just general disease and pathogen surveys, looking at, can we characterize and define flu in Pennsylvania ducks, not because we have a virus that's going to kill chickens right now, but so that we have that information when the next one emerges and comes through. So, a lot of it's just defining what's out there. And that's sort of what has gotten me excited over the last few years.
Wow. Well, you both have a lot going on, so thank you so much for making time to join us today. We loved having you here. I loved seeing your faces from far away. And yeah, thank you guys so much for sharing some perspective with us on wildlife research. And
Thank you.
Thank you guys, viewers out there watching too. This has been Untamed Unfiltered, and we will see you next week.
Bye, everyone.
Awesome. Thanks, guys.
Ready?